Hello, folks. I'm just going to ask if you could mute your microphone on, on your Zoom screen. It will help the sound quality of the video. We are recording the session today, so keep that in mind. You are muted for now. We will have an opportunity to ask questions at the end of the presentation, or you can write them into the chat box throughout, and we will go over them at the end. So the agenda for today, I'm going to introduce the Green Economy London program that is hosting this session today. And then we are going to hear from Bruce Taylor from Enviro-Stewards and Richard Hammond from Cornerstone Architecture. And then we will have a Q&A opportunity. So we'll try to get through the presentations first, but if you have questions, like I said, just pop them into the chat. And my colleague Natalie will pose them. If you would like to talk, though, feel free to unmute if you have an urgent question, or if you want to ask one of the presenters something specific. I'm going to go ahead and start and just quickly introduce who we are and why we're hosting this session today. So my name is Marianne Griffith, and I am the Director of Programs for the London Environmental Network. Obviously, as an environmental organization, we value water health, and we wanted to acknowledge that we do have 3 First Nations communities downriver from us in London, the Chippewas of the Thames First Nation, Oneida Nation of the Thames, and the Munsee Delaware Nation. And our hope through our work is that we treat our stormwater the best that we can, as it does go right into the Thames River here, or the Antler River, and it heads downriver to those nations where they use the river water for drinking. So we wanted to acknowledge that today while we were getting started. Sorry, that is me. I am a certified energy auditor and the Director of Programs for the London Environmental Network, like I mentioned. My colleague Natalie is here as well, and she is the Green Economy London Hub Manager. We are the London Environmental Network, and we work as a nonprofit organization in London to cultivate a healthier and more sustainable environment. We have over 40 environmental organizations in our network that we help support. And these are the programs that we're currently running. So Green Economy London is one of the London Environmental Network's programs, and that's who we are presenting as today. The Green Economy London program is in partnership with Green Economy Canada, which is a nationwide program that helps businesses set and achieve sustainability targets. We have some founding partners here in London that have helped us start out in 2019. These are the sponsors for our 2021 season, and these are the members that we have signed on. So all of the businesses that you see here have committed to setting sustainability targets within 3 years of joining our program, and they all have different goals, so we work with them individually to help them meet their goals. Our target areas are greenhouse gas emission reduction, environmental stewardship, waste reduction and diversion, and then what we're focusing on today is water targets. So we're hoping to help the commercial sector conserve water through our programming. In addition to helping folks set targets in those 4 areas, we also help them align with the Sustainable Development Goals that are pertaining to the environment specifically. So you'll see here that these 6 SDGs are in line with our programming, so we can help organizations report on any progress that they make in these areas. We have, like I mentioned, we launched in 2019, so we've been active for not very long, but we have had a lot of success in our first couple of years. So these are some of the highlights. We've gotten a lot of funding to help organizations implement sustainability projects. We've completed 50% of our membership's baseline setting, which is basically our biggest goal is to help people track their emissions and set a baseline and then improve the impact. So we're proud of that as well. And then we've helped people install and implement a lot of sustainability projects over the last couple of years as well. We've started an employee and volunteer engagement program where it's a month-long deep dive into the 4 different categories. So one target per week, and we help employers communicate the sustainability goals that they have with their stakeholders. What brought us here today is that we implemented a green project grant program where we got some funding to help organizations with their goals. And then we were able to give out the money and the opportunities, which included 2 water conservation blue roof feasibility studies. And we chose Pillar Nonprofit Network and the London Food Bank to receive those studies. And Bruce Taylor's organization, Enviro-Stewards, conducted the feasibility studies. So we are, through those initiatives and some of our other efforts with target setting, we have had 6 of our members set water reduction targets, including Good Life Fitness, spanning across all of their clubs, which is pretty impressive. And we would like to help implement these targets and meet them by doing retrofitting for low flow fixtures, etc. And then also looking at water catchment as a means for conservation. So we did have these studies done, and I'll let Bruce talk more about those. But that's where we were at with our water program. So if you'd like to follow any of our projects, you can check us out. Today, we are presenting on behalf of the City of London, Partners in Project Green, and the TRCA, the Toronto Region Conservation, and Green Economy London. So I'd like to thank all of our partners who helped put this on today. And without further ado, I'll make my introduction short and sweet because we don't have tons of time. So Bruce Taylor is going to start us off. He's the president of Enviro-Stewards, and Richard Hammond. They've both done considerable work in the commercial sector for designing and studying water catchment systems. So I will pass it over to Bruce.
Thank you, Marianne. Perfect. So hopefully everybody can see my screen.
Yes,
yep,
you're good.
Perfect. Okay. Well, appreciate everybody joining us today. It's an exciting topic and really happy to collaborate on this. And so put together a bit of a presentation here. I'm going to go through kind of the benefits, what a blue roof is, and some common barriers. And then we're going to use specific case studies. So one is Credit Valley Conservation and the London Food Bank and Pillar Nonprofit, which Marianne mentioned. The benefit would be, it's a really interesting opportunity for climate adaptation, and also to reduce your footprint of your facility. She mentioned the Sustainable Development Goals. So Enviro-Stewards received a Sustainable Development Goal for partnering for the goals, which is something that we're doing today. We're partnering with a lot of organizations to accomplish a mission. We're also B Corporation. I encourage you to check out that movement. Enviro-Stewards itself, we're about 15 people just north of Elmira, or of Waterloo. Our mission is to cultivate resilient business and improve lives. We're a member of the sister organization to this one, which is the Waterloo Sustainability Network. Here we're planting trees along the highway to Elmira from Waterloo. So first of all, you get the benefit of the trees and the greenhouse gas, but you also have less snow blowing in your face as you're trying to drive up the highway and improve your visibility. So that's just a side, you know, every employee gets 20 hours of paid volunteer time a year. So that's one of the projects we do. But our paying work is in North America. We work with commercial, institutional, CII, industrial facilities. So for example, Maple Leaf Foods. So they're the first large food company in the world to be carbon neutral. But interestingly, they're saving $12 million a year. So it didn't cost them anything. It cost them negative $12 million. And that's on the way you go about it. So if you just start, hey, we're just going to buy offsets for everything, it's going to cost you a lot of money. But if you first start with reduction, so we actually assessed 35 factories from across Canada and one in the States for measures to reduce it first and then offset the rest. And they had a Super Bowl ad last year on their carbon neutral status. They also sponsored water filters through the other part of our business is we do these safe water projects in East Africa. So we teach people how to build these water purifiers using locally available materials. takes no energy, chemicals to run, lasts 25 years. Then we teach them how to run a business doing that. And this is what this is. So if anybody's interested, there's a TED talk on it, and there may be a discussion after this session if you're interested. First thing we have to do is get our own house in order. So here's Enviro-Stewards. So we're in the situation that a lot of you are. We're tenants in a building. Our building happens to be 100 years old. And we didn't pay for water, right? It was just, so we actually literally bought a water meter, hired a plumber, cut the pipe, put it in. So we now know how much water we're using. And we're actually using 1/10 of the building code amount right now. So 90% less than the building code predicts. So one of the ways we do that is kind of high efficiency toilets and taps and sinks and that kind of thing. But here we're harvesting rainwater from our own roof. So the rainwater literally went through our office. So I just elbowed it in that tank, overflowed down the same pipe. I put it through a treatment system and into that living wall. We don't even have a pump, it's just all by gravity. And we haven't bought water for 5 years for that living wall. Just the snow melts enough to keep it going all winter. And due to COVID, it was postponed, but our landlord is replacing our roof. So once they do, then we're going to put a blue roof on our own roof. And that will improve our storage capacity 10 times for the amount of water, which would then allow us to tie in our toilets and other things also, and further reduce our water consumption. As part of Sustainable Waterloo Region, we made a commitment, like a lot of you will be making commitments in London one. So we committed to reduce 80% per employee. We reduced it 78% per employee right now, and we offset twice the remaining balance with sustainable development-based gold standard credits. And so also living wage and other things like that. But anyway, that's our own office. And basically what we do is we use that living wall where we literally suck the office air through it because it's tied to our return air duct to our rooftop unit. And according to our sensors, it's removing 97% of the CO2 we breathe. So instead of taking outside air all year long, we only take it 3% of the year instead of 100%. So we don't have to heat it up all winter. We don't have to cool it down all summer. And it's actually better air quality than our neighbor who doesn't have this, who's taking outside air all the time. So getting into this topic, so we had done guelph to wash the buses. And so the types of things we did was, first of all, let's reduce it. So better nozzles to wash the buses with. But then can we reuse the final rinse as the initial rinse, right? But then for the final rinse, right now they're using Guelph city water, which is hard water, similar to Waterloo's water, probably a bit better in London based on your water source. But by using rainwater, it's actually better water to wash a bus with than the city water because it's actually already distilled, right? So now you need less spot remover, need less soap, need less water. So in phase one, we captured the water from 850 square meters of the roof area into tanks and reused it. That was the installed cost for that. It worked so well that they had us capture the water from the rest of the roof, and that's what that second phase was. But the most of the cost of this project was actually the tanks to store the water and the piping to get it there. So it's interesting, what I'm going to present on the blue roof is you can avoid most of that cost because your roof itself becomes the storage tank. And when you're storing on the roof, you can actually get it to go down one drain instead of all the drains, you know, to where you need it. So you need less piping indoors and less tankage. And so it's an opportunity to reduce a lot of the cost of rainwater harvesting. So here's where blue roofs, and I'm going to use Credit Valley Conservation as a case study to explain some of these concepts. So there's potential stormwater benefits, water efficiency benefits, even some energy benefits. And so I'm going to go through a bit of that. As a starter though, interestingly, the Impact Center is funding part of that demonstration project that we're doing for CVC, actually building a demonstration one there. Why is the insurance industry interested? Well, the insurance is interested because the leading cause of personal claims is now water damage, and it's doubled in the last decade. Here's a chart on it, right? And so what's happening is we're getting larger storms more often, right? You might get a 100-year storm every few years, so it's not a 100-year storm anymore, right? It's a storm. And so what happens is all of our infrastructure was designed based on what we used to get. Now we're getting maybe the same rainfall, but it's in more intense, shorter periods, which overwhelms the distribution pipes, collection pipes, and then results in flooding. So interestingly, if we can slow that down so it's not going down the drain during the storm, then, you know, rather than digging up all the pipes, putting in bigger ones, taking somebody's land and building a big pond on it, right? Just by lower cost infrastructure improvements, we could potentially address the problem at the source. So we're assessing for them. We're actually building it on their head office in that picture on the left. We're also evaluating it at a neighborhood scale where, hey, 13 businesses are sharing the same storm drain that's overloaded. What if we were to collectively work on those? Can we address that at a community level? And then you could look at even larger scales if you want. There's two different ways you can go. One is called passive blue roof and one's active. I'll get into it more details later on, but generally speaking, passive is you're just slowing it down going down the drain. So it's not going down the drain at the same pace, and you're building it up a bit on the roof during the storm, and it's draining, continuing to drain down after the storm, and generally over 24 hours, it's all gone. Active blue roof is you literally store it on the roof. So you put a valve that closes on the drain, and we'll get into what that would entail in terms of the roof design and whatnot. But literally, you're storing it on the roof, and that gives you a lot of flexibility. First of all, you get a lot more water to use. Second of all, you can say, hey, there's a storm coming. Let's make some room on the roof. We're going to open the valve and drain the roof, right? So it gives you a lot of flexibility. They call that an active or a smart blue roof. So here's the Credit Valley Conservation, their headquarters. So the top left here, there's a lot of mechanical HVAC equipment. So we're not going to harvest the water from there as far as storing it up there. The drains are going to drain down the way they normally do. We're just going to use barriers to keep the polluted water from these areas. It's going to still go to the rainwater harvesting, but it's going to come at the same rate that it's generated. Over here, we're going to do an active blue roof where we're actually going to do it with control valves and maybe even a passive component over here. And it's going to end up in the store tank in the basement. So similarly, here's a side view. So basically, you've got some control valves here. So this allows you to keep the water on the roof until you want it. Here's your stormwater harvesting tank in the basement, which already exists. They're already got their toilets tied into it. So this would give them more water so that they have to add less city water to make up the difference. But basically, as this tank calls for water, it just open a valve, top up that tank, and you keep going. And then if you need to clear the roof, you can just open it up and drain it to the town, to the storm drain before the storm occurs when there's more capacity in those pipes. As far as the water itself, it's going to come in, you might settle out some debris first and then store it. And then before you use it, you might treat it with ultraviolet light or chlorine or something like that, and then use it in the toilets. Now, interestingly, we don't have to make drinking water out of it. We just need to make toilet water out of it, right? And so it's a lot easier than the level of treatment you would need for that. So this is being the detailed design right now, and it'll be tendered soon for construction, most likely this year. So then it comes back to some common considerations or push barriers to consider. So one is, as soon as I say we're going to start storing water on your roof, immediately you think, well, is the roof going to hold it up, right? So the WSP structural engineers, they did the evaluation of the building codes going all the way back to before the 90s, 90 to 2005, after 2005. How much water can you store on a roof if the building was built to code at any time? So basically 120 millimeters during this period is the low point, right? So it was actually stronger before the 90s. So even 120 millimeters, 12 centimeters. So, 10 centimeters of water will be less than the building code. And so what happens is, let's say in the wintertime, we would actually drain the roof. So you still got your snow load left, but during the shoulder and summer season, you can store water. And if you got a big storm coming, you can just make room on the roof kind of thing. And so there's a nice report. And in this recording, hopefully you'll have the slides that you can click on this to get to this site, where this is actually the feasibility study for that project that Credit Valley Conservation made. Another consideration would be mosquitoes. So aren't we going to grow mosquitoes on the roof? Anytime you got ponded water, right? Even in your own backyard, you want to be careful of this, right? So you have a screen on top of your rainwater barrel, that kind of thing, to avoid this. So if you look at the life cycle of a mosquito, the eggs can last for a long time, even in a dry environment. And then once they see water, within 2 or 4 days, they hatch into larvae, right? So interestingly, the larva has to be in water, and it takes 5 days before it becomes what's called a pupa. And then it takes another 3 days minimum for it to become a mosquito. So there's 8 days. So if we were to ensure the roof drains at least once a week, right? So let's say every Friday at 5 o'clock, you open the valve and you drain the roof, right? Let it dry out for a day or more, close it again and start storing it to dry out things. So any larva and pupa would be killed, right? It's kind of where that goes. So another interesting thing is cooling. So if you go on a roof in the summertime and you touch the liner, you may actually even burn your hand. That's how hot it is, literally, right? Because the sun's beating on it. If you go to a pool, outdoor pool, put your hand in there, it's not going to be hot. It's going to be like low 20s at best. Because once you get above that, you get more and more evaporation, and that evaporation cools that water down. So you could potentially keep your liner at closer to 20 degrees than 40 degrees or whatever it's going to heat up to, which I think may have some benefits in terms of the life of the liner, because it the cooler it is, all the plasticizer and everything in there would last longer, in my opinion. But also interesting on the building. So if you have a 40 degrees Celsius liner and you have a 25 degree building, then the heat is going to go from that liner through the roof into the building. If you have a 20 degree liner and a 25 degree building, then the heat's going to go from the building to that water, so the opposite direction. If you look at that swing, 21 gigajoules one way and 13 the other, that comes to 34 gigajoules of energy. Now, your building's refrigeration, your air conditioning system, can move, is fairly efficient. It might be able to move 3 units of energy for every unit of energy you put in. So if you did that, it's still a certain amount of electricity you're still going to save on your HVAC units. It's not going to be a lot, but it might be significant. And also, if you don't have refrigeration, it might give you a little bit of cooler environment for your workers in your building. And then the larger the roof, the bigger the benefit, kind of thing. So now some specific case studies from London. So the food bank is in London, and they actually have a garden, which is really nice, and planting trees and that kind of thing. This is their roof. They have a little rainwater harvesting tank in the top right there, and they fill it up about a cubic meter a week. They bring a truck for that gardening. So they're paying somebody to haul that in, right? Which we could potentially avoid that cost if we harvest their own rainwater. Also, they're building this hoop structure, so an indoor greenhouse. And so, this is perfect. Rainwater is perfect for growing plants, right? So what if we were to harvest that? So basically what we want to do is, there's the two roofs there. The north roof, that's that little tank that I showed you. If we put gutters on here, we can have one tank here, another one here, because they also have a trees that they're trying to do out here, and basically just harvest the rainwater from that peaked roof they have. The main flat roof here, it's not good for a smart blue roof yet because of the type of material. So we are considering a passive blue roof, which is basically a slow release, but basically capturing some of these drains inside and getting it over to that greenhouse so they can have a storage tank there that would fill up whenever it rains and use it in the plants. On the right here, this is a software program we use called Connect the Drops to model rainwater harvesting systems, and then we jury rig it to also address blue roofs on top of that. But the blue bars here is how much of the actual water demand they can satisfy, is kind of what that is, and the hatched part is the part that still would be needed to met with other water sources such as city water. So in their case, interestingly, before you start reusing water, it's better to reduce it in the first place. So by changing the fixtures in the food bank, we can actually save 100 cubic meters a year of water every year, whether it rains or not. On top of that, if you put a passive blue roof, you'd save an additional 70 cubic meters. If you're able to do an active one later on, if they replace the roof liner ever, then you could get in the realm of 230 on top of the 100. Innovation Works is in downtown London there, 201 King Street. It's a nice old building, 4 or 5 stories tall. Similarly, its roof isn't ready yet for a smart blue roof. So at this point, we would only consider a passive blue roof. Later on, at some point in the future, you may put on a modern roof liner. At that point, you may want to consider converting to an active blue roof, but most of the infrastructure in the facility would already be set up. So basically in this case, because of the design, what we would do is put one, it's 4 stories tall. We would put a tank, I think it was the 3rd or 4th floor, to get rainwater from the back of the building and reuse it on those 2 floors. And then on the 1st floor, put another tank that will get the rainwater from the front of the building and reuse it there. So the nice part is it's actually in kind of a communal area, so people could see how it works, how the water's treated, how it's reused, kind of bring it top to mind to people to do it. But just through water consumption, they're presently consuming that much a year, but through conservation, we could save about 300 cubic meters a year with fixtures and that kind of stuff. And then if you do a passive blue roof in those two locations, you could save about this. And if you convert it to active later on, you could save a total of that much on the blue roof reuse side of things. So interestingly, from a stormwater modeling perspective, this is the instantaneous amount of rainwater going down the drain during the storm that can be avoided, right? Which has a lot to do with sizing of the storm pipes and flooding risk, right? Through the water conservation, there's this kind of available through the buildings, and through the reuse with the blue roofs, there's these kinds of things available. Plus you get a small amount of savings on the cooling in the summer months. And so what I want to do is throw it open to Q&A.
We've got a couple of questions so far in the chat for you, Bruce. And some you might have touched on, and I think one of them might be better suited for Richard, but we'll go through what we got. The first one was, how large and how small can a roof be to be supported with this system?
Well, our own office is 5,000 square feet, and we're going to put one on our own office in Elmira. And we already have the rainwater harvesting like I showed you. So you can start small. Like the drain pipe literally went through my office, and we just started by just buying this tank and elbowing in a tank and overflowing down the same pipe, right? So that's pretty small, and we didn't even get this pipe at the back. We just did this one right here, right? And just that alone was enough to keep this wall going for 5 years, right? So you can start pretty small, and it will a lot depend on your roof liner. So basically, the old type of roofs are, the tar and gravel and different things like that. You don't want to store water on there. What you need is kind of a modern, where they put on the plastic liners and they weld them together. So literally you've got a swimming pool liner on your roof, right? So if you're going to store water, you need something like that, right? And so in our case, we just have to wait until COVID's over and they replace our roof liner, and then we'll have a smart blue roof on our own roof, right? In that case, all I'll need to do is buy a valve, put it here, and store the water on the roof until I want it, and I'll let it down to this tank to reuse it. And if a big storm's coming, I'll just empty the roof. So you can start fairly small, and even at the food bank, that one roof's fairly small, and it's a peak roof, which you don't want to store. You can't store water on a peak roof, but we can at least get it in a tank and use it.
Great. The next question was, how can you ensure either your tank overflow or the flow rate is sufficient to deal with the worst storms? And I think you kind of touched on that. But.
Yeah. So in our case, it's coming in here. This is just the same size as the roof drain now. And our overflow, you can't see in this picture, is out the back. And we've got, I don't know, a foot or above that, right, that the water can go up in our thing and basically overflows down that same pipe. And so that's how we deal with that. If you are storing it and you're going to let it down, say on a Friday, like I was saying, then you can pick how far open do you let that valve open so that you don't overload it when you let all this down at once.
Perfect. In addition to mosquitoes, the ponding water on the roof may attract fungal growth. Do you have any experience dealing with this, or do you know how you deal with that if that was something?
Yep. Great question. And so fungal or algae would be another consideration, right? Basically, Credit Valley Conservation is going to build it themselves this summer, right, on their own roof, and see what that is, right? And so it's fairly high up, and so we can always, the timing on anything, you can adjust it. So hey, we're only going to store 5 days a week, or you can make your own things on how you're going to minimize that. And then you may need to have a maintenance component of, say, pressure wash the roof once a year or something like that.
Natalie, for the sake of time, I'm just going to get Richard to start up, and then we'll shelf the questions until after his, if that's all right.
Sounds good.
Yep.
Thank you, Bruce.
Yeah, thank you. Stop share. Okay.
Hello, everyone. I share Bruce's excitement with this topic, so it's great we have a crowd interested in other things you can do with your roofs. A little bit about me. I founded Cornerstone here in London in 1991, and we've developed a large portfolio of sustainable design projects. That picture actually is the first LEED certified project in this area for the Congregation of St. Joseph's in 2007. As part of that process, I became a LEED accredited professional myself, and then there's also another rating system called Green Globes that we use a lot. So I'm a certified Green Globes professional. And as these issues become more complex, I tried to inform myself a little bit more about the issues at hand. And so I did a graduate program at Arizona State University at their School of Sustainability in 2010. And in 2016, I received my master's of Environment Resource Studies at Waterloo. And that is what I'm going to talk about today. What I chose to look at was the impact of roofs on cities. And the humble green, or the humble flat roof, is a large presence in an urban area. In fact, it represents about roofs as a whole represent about 25% of a typical North American city. It's actually a greater area than pavement. The way I see flat roofs, they're kind of hidden landscape. They're hovering up above our heads. We never think about them until they start to do something wrong, like leak. But they're really a tremendous resource that I don't think we're taking advantage of. So the two questions I looked at were, what are these impacts on our cities here in Canada? And which is more effective at addressing them, green or blue roofs? So the humble flat roof does a lot of things for us. Especially in our climate, it resists the wide range of temperature and precipitation that we get. It keeps us shaded from sunlight. And all these services have impacts on the urban environment. So a dark roof in the summertime will heat up, as Bruce was saying, and will radiate heat back into the city. And that creates what's called the urban heat island effect. That's what makes cities so hot in the summertime. On the other hand, we're using more and more white roofs, so-called high albedo roofs, and they reflect light. So that helps reduce the heating effect, but it can cause glare problems for neighbors. The roof does transfer heat through it, especially if it's a dark surface and it's heating up. But the most important impact I feel of roofs and their primary function is rainwater collection. And that collection, especially in large storms, is discharged directly to storm infrastructure in cities. And that leads to contamination of the waterways, especially in older areas of cities that have combined sanitary and storm sewers. A heavy storm will flood the combined system, and we're discharging untreated sewage into our water courses. So quite a significant problem. And fortunately, we have a large selection of strategies to address this. And so what I'm hoping to do is kind of put today's topic of blue roofs into context of that portfolio of things that we can do to mitigate these impacts. They're part of what are called low impact development, stormwater management. And you can see on the top of that chart, there's a few that are based on the building, on the roof. And one of them is rain barrels. Somebody asked a question about what can you do with your house? Well, a very straightforward approach is to put a rain barrel under one of your downpipes and use that for irrigation outside. The cistern or blue roof is the main thing that we do in our larger projects, and that's what I'm going to be talking about a little bit more. And then a green roof has a lot of other benefits, extremely effective from a stormwater management point of view. And all of those things are what we can do on a roof and what I looked at in particular. The rest of those strategies are all on the site: infiltration, bioswales. There's a number of other tools that we use on our projects, on our project sites, to further mitigate stormwater. So I'm going to dive into some facts and figures here. This is sort of a synopsis of the results of my work, looking at a number of building types here in London. And the results of the modeling that I did compared for blue roofs compared to the performance of a green roof. So to explain a little bit about what you're looking at, that line is the average performance of a green roof here in our climate. London happens to be an absolutely perfect place for green roofs. They store on average about 75% of the rain they receive. It's absolutely remarkable. And what I looked at was how do blue roofs perform in comparison to that. So you can see there's a variety of different building types across the bottom of the chart. And the blue dots are the percent of the rainwater that those blue roof systems divert if we use that water for toilet flushing. As Bruce alluded to, there's a difference between the water quality that we need for flushing toilets versus drinking water, and all our projects, the water we use inside is strictly for toilet flushing. And if we do that, you'll see some projects perform comparably to green roofs in terms of the amount of rain that they keep. A few don't do as well, and they're because they have relatively few people under the roof, right? Or they're intermittently occupied. So some of our public buildings, aren't a great choice for blue roof systems, and many office and retail buildings, there's just not as high a concentration of regular users of water as there is in some of these other building types. So that's where some fit and some don't. The big point I want to make today, as conveyed in this chart, the green bars are the demand in each case for water in that building for flushing toilets. The blue bar is the amount of water that building receives in a year. Every blue bar is bigger than every green bar. So every single roof on these buildings receives enough rain that it wouldn't require drinking water to be flushed down the toilet. And yet most of these buildings are taking drinking water and literally flushing it down the toilet. And all of them have enough water in a year to avoid us doing that. So why consider green or blue roofs? And I think they offer, beyond the stormwater management objectives, a lot of other benefits, both to the building and to the urban environment around the buildings. So that little table shows you some of the key things that I've identified as benefits in each case. So as I said, they both do a great job managing stormwater. They also both perform well from an urban heat island reduction perspective. One of the big benefits of green roofs, of course, is to create natural habitat on a site for pollinators, and even birds use them for nesting. Blue roof, not so much a reliable solution for that. On the other hand, blue roofs conserve drinking water, either for irrigation outside, for toilet flushing inside, and even there's examples of using it for all the water needs inside a building. And they're also much more compatible with solar photovoltaics because you don't need to access the roof to be maintaining the green roof if it was underneath the PVs. Green roofs win hands down on the sexiness category. There's an image from a famous project in France from the 1930s, actually. They are absolutely beautiful. And it's hard to get people enthused about blue roofs and the technology that goes behind them. You can see the typical schematic at the top of that slide. Most of our projects store the water outside in an underground cistern, actually, because of the volume involved for the buildings of the size we do. And there's a lot of bits and pieces to making those projects work. So the answer to that question, what's more effective, green or blue roofs? It depends. And so this is really, this last slide is the kind of key outcome of my work to help designers like me decide what is the best fit, help advise our clients, what's the best fit for your project. So you have to start with a philosophical decision that you're willing to consider stormwater management for your project. Second question is, have you got funds available? These strategies do cost money. It is an investment in the performance of your building. But there is a solution even if there's no real funds available, and that's the system Bruce alluded to, a so-called passive blue roof, or what we call flow control roof drains. You just slow down that heavy rate of storm water over the course, usually 24 hours. You know, you have a restriction on the roof drain that slows the flow of water down for a day, and that reduces the worst of the impacts. However, for those clients that are willing to, we find for a large project, these systems are about 1%, you know, in terms of order of magnitude of the project cost. So it's not insignificant, but it is still, you know, a minor piece of the big of a big project. So we have some funds to invest. There's 3 interrelated decisions, almost like a voting, that I've identified. Number 1, is the roof surface visible? And if it is, and we can see it from the building or from the neighboring roof, that would favor utilizing a green roof and taking advantage of those wonderful aesthetic benefits that the green roofs have. Is habitat limited on or around the site? And again, in a you know, urban core where limited amount of open space, again, the value of the habitat creation by a green roof is important. And finally, are we doing anything else on the roof? Are we putting PV up there? We got a lot of equipment up there that interferes with the access and maintenance of a green roof. If there isn't, again, that would favor a green roof. Conversely, if we can't take advantage of the visibility of the roof, if there's already, you know, a lot of open space on or around the site, and in particular, if we're doing other things up there, that now tips the balance, in my opinion, towards considering a blue roof. And the final decision is, can we use the water, or to what degree can we use the water? You know, which kind of building are we in? How many users of water do we have inside? If there's limited demand, that's what leads us back to the bottom of that chart you saw before about site infiltration strategies. And if we can use the roof, in many, many cases, there's a great demand for that water inside the building, then that's what leads us towards a rainwater harvesting system. Most of our projects combine all of these strategies. It's not an either or. Some parts of the building have a low roof that may be visible. Other parts lend themselves to rainwater harvesting. And in almost all our green projects, we still do infiltration. So there's very, very little stormwater discharge once it goes through these processes. So for more information, my work was published in High Performing Buildings magazine. There's the link online to that. If you're really dying for lots of detail, you can read my thesis. It's on the Waterloo website. There's lots of information about our sustainable design projects on my firm's website, and you're certainly welcome to email me. Thank you very much for being enthusiastic about doing things with your roof.
Thank you, Richard. I'll snap for everyone. Natalie, are you ready? There's a bunch of questions, so maybe Bruce and Richard can just tag team this too, and you can talk over each other to get to the bottom of these questions.
Sounds good.
Awesome.
All right. One here we had about cost estimates. So do you have a relative idea of what the cost estimate would be to put a plastic liner on your 5,000 square foot office roof?
Yeah. So I actually didn't pay attention to it because we have to do it like the landlord just said, I'm replacing a roof, and we're on the 3rd floor. So he's taking the roof cost, dividing it by 3 floors, and dividing it by, I think, 5 years. So I didn't, because it was a cost we had to pay anyway, I didn't really stick in my mind, but I can look it up if somebody wants to send me an email. I suspect it's in the neighborhood of like 10 to 20 bucks a square meter or something like that.
Perfect. Are most 50-year-old industrial buildings strong enough to hold the water if you just install the blue roof plastic liner on the existing structure, or will they have to strengthen the roof to hold the weight?
Yeah, so as long as it was built to code at any point in time, then there's more than enough capacity. They used to build stuff even stronger, you know, until they started dialing it back with better estimating for roof loading and stuff. So if, you know, with the caveat that if it was built to code, right, and then you don't actually store it in the winter time, right, you just rely on the snow melt during the winter time, and so then you still got your snow load back.
Makes sense. This one's kind of to do with, like, again, the structural engineering analysis. Someone commented about how you need one for solar panels, and they're assuming that the roof, a blue roof, would be as demanding or more demanding. That was part one of their question. And then can you speak to how engineering requirements have been met in the past, and the related costs, and to the types and ages of the structures that may not be worth pursuing for a blue roof?
Sure. Yeah. So say like in Credit Valley Conservation, they hired a structural engineering firm, which is called WSP, to actually evaluate the roof to confirm. And, you know, they're designing the scuppers and that kind of stuff, the structural components. So I would, if you're actually going to do it, I would recommend hiring an engineer to evaluate your roof. But if you suspect your building wasn't built to code, then that would be a red flag. As far as the solar panels, remember I said we're doing that one where 13 businesses are sharing the same drain. One of them actually has solar panels on it. So we don't actually want to put an active blue roof on that one because you don't want electricity and standing water. And so we're probably going to do a passive one and then just have the caveat that don't go on that roof until it drains down again.
It's, as I mentioned, it's why most of our large systems are underground. We use cisterns because almost all those projects have PV on the roof, and you know that consumes a lot of that available capacity.
Yeah.
All right, we've got one that's dealing with areas that deal with extended periods of drought. So they're looking at designing rooftop landscapes in BC, and often have 12-week drought periods. Storage requirements for irrigation require huge tanks. Can you comment on how effective a blue roof would be in these kind of settings? Reuse for flushing toilets could work, but we are often told the cost to do this is prohibitive. Same with the structural upgrades for the new building to hold water on the roof.
Yeah, so particularly in the interior of BC, that's technically a desert, right? And so that would be an issue. So that particular program is called Connect the Drops that we just used, but you know there might be others also. You know, whatever city you're in, you put in the local weather, and it's going to predict if you had a tank of this size and you can consume at this rate. You know, how much water could you use, and then you could determine if it's worthwhile for you. Rainwater reuse systems tend to be less cost effective. Like conservation is definitely, you know, a few months maximum. You know, to do something to not use water in the first place. So it's always best to reduce first, but as far as the reuse, you want to evaluate to see what the economics are. I don't know if I've answered all the question there or not.
Yeah, I think you did.
Yeah, okay.
We've got one about building code. The Ontario Building Code states that the maximum drain time on the roof shall not exceed 24 hours. Is this applicable to blue roofs?
That's a fight that CBC is doing right now with them, right? And so that requirement was put in before people started considering blue roofs, I think. And so it's something that, you know, somebody needs to fight that battle to, you know, why do we have this, and what's the root cause we're trying to solve? Is it mosquitoes? Is it what, right? And how
I agree. It's a matter of education. You know, it was a precautionary thing that people worry about having roof water up there too long. And even roof membrane manufacturers now are getting more comfortable with ponding on the roof. There was a time where you would void your roof warranty if you had too much ponding, but you know, it's education. We're seeing more examples. And as Bruce says, you know, what's the issue? Are you worried about mosquitoes? Well, there's great evidence that if it's an open roof that's open to the wind, that's just not going to be a problem. So
Bruce, can I chime in on this one from CBC?
Yeah, sure. Thank you.
This is Rohan from CBC. I'm involved in the project there, developing the blue roof. And yeah, we're facing this question. And there does seem to be openness to looking at alternative solutions to meet the intent behind that 24-hour drawdown time, which they've stated is to prevent the buildup of contaminants. So if we can show that we are preventing the buildup of contaminants using an alternative approach, then we may be able to get around that 24-hour limit.
Perfect. Thanks, Ryan.
Next question we had, what source of water uses less energy, city tap water or blue roof water, as both sources would need pumping and water treatment? I think.
So in our particular case, we don't have a pump. So, because it's falling from the roof, right? And so then when you store it in the tank, you know, it goes from there to the thing. But even if you had a little pump, it's going to be a lot less than city water, because to procure city water, you got to pump it, pressurize it up to 60 PSI, get it to wherever, use it, then take it back again, aerate it, pump it a bunch of times, and discharge it. And interestingly, a lot of the footprint of most towns is actually just water related. And so when we do our energy projects, we actually include the embedded energy of the water and the water they save when we do our GHG analysis for them. Just because it's, you know, we don't really think of it as back of mind, but it takes a lot of energy to give you water and then to treat it afterwards. And it's essentially free. So in our case, all we have is ultraviolet light. So it's less, it's basically one bulb, right? And so you can imagine what one bulb out of your fixture would use in a year. And then once a year we replace the bulb, right? So $110 or whatever a year. And then every few months we replace the filter, right? So it's not a lot of operating costs to maintain a purification system.
Perfect. I kind of answered the next question. One part of it was, is it required, do you have to have a UV treatment required to do it in the toilets, or can you bypass the UV infiltration?
Oh, good question. Well, this gets back to the bylaw kind of stuff, you know, like and so like technically, like it's really a bad idea to drink straight out of the toilet anyway, right? And so whether or not a bird poo bacteria got in there or a human one, right, it doesn't really matter. You shouldn't be drinking it. So from a purely technical, you know, yeah, you don't actually need to treat it. But as far as to get it through permitting and other stuff easier, it's a low investment to just treat it, to put it in there with either of those types of things where you're just taking out the big bits, if there are any, and then ultraviolet light kills the, you know, messes up the DNA of the bacteria so they can't reproduce, or else you just add chlorine.
I'd like to chime in on this one, Bruce, because it's been a big challenge for us on our large institutional projects. You know, there's a CSA standard for non-potable water use you may be familiar with, and it's extremely conservative. And if you follow it to the letter of the law and you're a conservative, you know, institutional building owner or municipal permit official, you know, it pretty much requires polishing that water to essentially drinking quality standards because it could have human contact, right? And again, I think it's just a matter of education and, you know, research in the water sectors says that there's we shouldn't think of water as an undifferentiated substance. There are many waters, plural, for different purposes. And, you know, as you said right at the outset, I think we need to think of it as toilet water, if that's what we're doing to do with it, not drinking water, and get more comfortable. And, but certainly, yeah, that's been a big issue. We spend by far the largest portion of the cost on our harvesting systems on treatment. It's way more than the cistern.
That's crazy.
And I mean, these are huge, you know, institutional buildings like at the university and other, you know, long-term care and, you know, those kinds of environments where people are very, very cautious about these things. And so that's been a big impediment for us, the water quality requirements in our buildings.
Yeah, oh, thank you.
And our last question in the chat here kind of dovetails on the what we were talking about permits and stuff. So they found that the current permit approval infrastructure limits the ability to pursue a blue roof implementation opportunity. How have you overcome some of these challenges that may happen?
Unfortunately, it comes down to who specifically is reviewing your application. And so I remember another project we did for Credit Valley quite a while ago, and we wanted to have a low-cost stormwater protection. So basically, your stormwater, people don't realize, but it's not treated at all by anybody. So if anything gets in the stormwater, it's going right to the river untreated, right? So we're doing a chemical factory, and their loading dock was below ground, so they back into a hole, right? And unload out of the back of the truck. So, and the bottom of that had a storm drain. So if you ever spilled chemicals from that during that process, it would literally go directly to the stream. So we wanted to put a valve in the storm drain on the property and close it whenever they're unloading, so that if you ever had a spill, it would stay there, right? And you can deal with it. And then you just open it. And we had the toughest time. We eventually did succeed, but that was the hardest part of the whole project, was just convincing the local building, even though if it, if worse comes to worse and you leave it closed, it still would never reach the inside of the building because of the way it was designed. But just because it had never been done before, or I'm not sure what it was, but so all that to say, when I did our own rainwater harvesting in Elmira, I was expecting something like that. And when I presented to the local building, yeah, go for it. And we literally elbowed it into a tank, overflowed down the same pipe, and we're done, right? So it really depends on who you get specifically, unfortunately.
In our case, notwithstanding what I said about the water quality issues that are the biggest challenge for us, the building code actually does discuss non-potable water systems. They just have to be labeled. You can't run a non-potable water line over a sink that's used for another purpose, right, in case there's a leak, I guess. But it's actually relatively straightforward once you're in the building.
Mm-hmm. And then think about all the things that you can use it on. So toilets is obviously, right, but urinals. Rainwater is also good for cooling towers, right? If you talk specifically with your cooling tower vendor on what you're going to do, because you're just going to evaporate it again anyway. Vehicle washing. So the more things you can get to consume the water, the more the economics works, because the more of the water you're able to reuse beneficially.
Great, that's all the questions we had in the chat. Is there any other last minute questions anyone has? Feel free to unmute yourself.
One came in. It's how feasible and efficient would the blue roofs be for residential homes?
So a challenge would be almost very, very few residential homes would actually have a flat roof. So in a blue roof, you're literally storing the water on the roof, which you couldn't do it at residential. But if you're interested in, say, rainwater harvesting and reuse, then it is a lot more practical. And most homes used to have it, right? 100 years ago, you'd have a rainwater cistern and you'd use that. And in the modern era, rainwater harvesting from your gutters is very, very doable, and you can daisy chain them together and that kind of thing.
Every house in Bermuda has a rainwater harvesting system.
Let's go there.
Every house in the country too. It's called a well.
Yeah. So perfect.
Okay. Well,
I actually have a question.
Great.
Yeah.
Have you seen any pushback from municipalities where typically you pay for water disposable when you bring fresh drinking water into the building? Now that you're going to be adding significantly more water down their treated systems, have they talked about the added cost to a building with a blue roof that is now, not paying for the water coming in to be treated going out?
Yeah, no, that's a great question. I would say that the in our case, our living wall, it doesn't actually go down the drain, so we don't get either thing. But let's say for whatever reason it is going to the drain, once we start going to the toilets or something like that, we can buy a residential turbine meter for $300, and we can strap a pulse counter on it, and we can literally pay the sewer bill on that water if we want. So we don't have to pay to buy the water, but we have to pay to discharge the water, would be the way to address that. But yeah, once you just
remember, we're not increasing the rate of water going into the municipal sewage system, right? It's just the source of that water is changing, right? So you're not flushing the toilets or using the sinks anymore. So that water is still the same. It's just where it's coming from. And so municipalities have twigged to that. Where we have a rainwater harvesting system, they know that that's reducing the amount of drinking water our client is paying for, even though it isn't necessarily changing the amount of sewage. They still have the same number of toilets, right? And so some municipalities have twigged to that. And as Bruce said, we've in some cases had to provide supplementary metering for that reason. Meter the non-potable system, so we have a total consumption that goes down the sewer.
One other co-benefit I didn't mention is, say like if you're in Mississauga or somewhere where you've got a stormwater fee, these types of things can significantly reduce that fee, which can help with the economics.
In London,
there's
there's also an incentive.
Is there? Wonderful.
I don't think anyone's actually used it yet, but it does exist.
Development charges are a huge issue in the building industry, and they are meant to pay for infrastructure. And so some municipalities are being open to argument that, hey, this is reducing the load on municipal infrastructure, and therefore is an argument to reduce the development charges for a project. And that's a very big incentive for our clients.
Yeah, and Credit Valley's finishing up their study now, but basically if you just did regular development to address this flooding issue versus doing this in the same community, and I think it's going to be really favorable on the economics, rather than digging everything up.
A couple more questions came in. Is there a possibility to provide municipalities with water that might be considered extra?
Yeah, that Credit Valley one I just mentioned, we're also looking at sharing water. So, this facility doesn't have much people, but it's got a big roof, right? You put your cistern in between that one and the next building that has a lot of people and not much, or not a suitable roof, or they're washing trucks or whatever. So, geographically comes to bear on it. You don't want to add it to the whole municipal. If you don't want to add it to the municipal system itself, because then you're going to have to prove that it's drinking water quality, right? Whereas you can have kind of small dissociated systems that are maybe 2 or 3 consumers off of that system would be I think a better model for that type of thing.
Where municipalities may purchase their own treated water from themselves, and they are largely fixed operating costs for the operating of the water treatment facilities. What is the business case for municipalities to implement blue roofs on their own corporate rooftops?
No, that's a great question. So one is PPG, one of the partners of the thing, also commissioned a study of the water conservation programs in Ontario. So at one point we were involved with managing each of them, and so we wrote a report for them that's available on their site. We can send a link later. And so a lot of municipalities haven't caught up. We're selling water. Why would we want to conserve water, right? But the cost of supplying water isn't just that, right? It's job retention. It's capacity. It's maintaining this thing. It's so a lot of them have got to the point where it's cheaper to pay somebody to use less water than to get more capacity yourself. So once they reach that, then they start water conservation programs. And so London's actually starting in the fledgling stages of starting their own water conservation program, which is great to see. If they're buying it from themselves, it still costs them. So even say Toronto, we did theirs, and we did some of their facilities, and because you still got to make that water, even if you're buying it from yourself, right? There's still you still got to buy that electricity to run that pump, right? Whether you're selling it to a customer or you're using it yourself. And because of that mentality, you might even be wasting more water than a conventional one because of the perception that it's less valuable than it actually is. So, and then the other thing is to think about the inherent value of water, right? So is the value of water just what it costs us to pump it out of the ground, or is there more value to water than just our cost of moving it around? And so if that's the case, then there's inherent interest in reducing water in the first place.
I mean, because we spend so much, or the water costs so much, even if it's so valuable, it costs so little. It's very hard to make a sheer financial argument for a rainwater harvesting system in any of those buildings that we do. But there still are savings. And even though it's hard to capture, Bruce, I'd be interested to know if any of your clients have looked at it this way, that there is a maintenance cost, and the savings easily pay the annual maintenance costs. I just don't know if they get captured, right? Because the water bill goes down, great, that money just doesn't go to the water bill, but it doesn't get funneled to filters and UV bulbs, and so they become an extra line item on the annual maintenance budget. I'd love to see a way to connect, hey, you're saving this water.
That was a great point,
let's just, flow that budget over to looking after the system at least.
Yeah.
While you're
Yeah,
on
Mark-
that topic, someone also asked what kind of maintenance activities are required for a blue roof.
Uh-huh. So on the treatment side, like I say, like our own system, it probably costs us under $200 a year to on the water treatment, because basically it's one light bulb and 4 filters a year. On the roof itself, we've included a line item for maintenance, which would basically at this point we're imagining, because it's a demo pilot that we're going to do, but basically to pressure wash the roof once a year. But maybe Richard has more thoughts on that.
Well, I mean, it depends what you're doing with the water, right? So if you're using it for irrigation, either exterior or inside, as Bruce has done with his lovely living wall, the requirements for, treating that water are lower, and therefore your maintenance costs are going to be lower. As I said, that's a big challenge for us. The treatment level that our water that goes into the toilet has to go through is quite elaborate, and there's significant costs involved. And yet that's comparable to the savings that our clients receive from not having to buy municipal water.
Mm-hmm. Thanks. And you just remind me too, like one other benefit is for outdoor irrigation. Yeah. Like the challenge is if you're not storing water, then the time that you've got the water isn't the time you want to water anyway, because it just rained. But if you can store water for up to a week, then you are going to, maybe twice a week you're going to be watering anyway or whatever. So you're going to be able to reuse that rainwater, and it's better than the city water for plants.
All right. Well, that is all for the questions that have come in. So unless anyone wants to speak now or forever hold their water on the roof, I'm sorry about that. Well, thank you very much, Richard and Bruce, for your time, and the team at TRCA and Natalie and the City of London for your support. We are recording this, so if you are so interested, it will be on the Green Economy London YouTube at some point in the next 48 hours. And Bruce, we have gone over time, so it's up to you if you want to stay around or not.
Okay, I can stay for a few minutes. Let me just check.
Basically, Bruce has a really cool safe water project that his group initiated. And if you have time and you're a water nerd, then you might want to hear about Bruce's other projects too. So he was willing to stay and chat about the Safe Water Project.
I definitely want to hear about it.
Excellent.
Oh, maybe just me and you then, we'll see. But anybody who's interested, feel free to stay on. And thank you all for joining the workshop. It's wonderful.
Thanks, folks.
You guys are getting lots of compliments in the chat box as well. So read those
Go and do your own blue roofs or green roofs.
Mm-hmm. So if anybody's still on, so our business model, Enviro-Stewards, is to generate our revenue here in North America, and then to help with development work in East Africa. If you have 13 minutes, there's a TED talk on it, which I won't show now, but just go to YouTube or to the TED channel and just put in "better than charity," and you would get to that. And it's all on the topic of why we do it this way instead of the normal way. If you think about it, almost every commercial you've ever heard for helping people is rich people giving stuff to poor people, which literally creates damage. And the TED Talk explains why that is. The short answer is, Richard, if I started, I can't because I'm not an architect, but let's say I started giving free architecture in London, right? Until I drive you out of business, then I can charge whatever I want. That would actually be illegal for me to do. But that's how we do 100% of our aid, is we go wherever it is and we provide free medical, free education, free water, free whatever it is. Whatever capacity was there wasn't enough, but now it's destroyed. And then when we get bored and we go somewhere else, there's no capacity left. And then we blame the recipients, hey, right? And similarly on, so we want to get back and change the foundation. We start with the land acknowledgement. In our case, our land in Elmira was leased from the Six Nations for 300 years, but nobody's paid rent for 300 years. And so rather than some handout for the drinking water system, why don't we just pay what we owe them, right? So anyway, Enviro-Stewards itself offers to do that. And I'd like to see a movement grow along those lines, but you can't just, if you had a house and you rented it out and they didn't pay rent, you wouldn't be that excited if they gave you a freebie handout. Just pay me what you owe me, right? So we want to get back to this kind of thing. And so in the world of safe water in developing countries, it can be self-supporting. So even during COVID, our project expanded. Most projects contracted because donations went down and that kind of stuff. We actually started a new project in a new town during COVID. And this is how we do it. So we've actually done it in South Sudan, some of Kenya, and now in northern Uganda because the war was too bad in South Sudan. And now what we did during COVID, we had a bit of extra time, unfortunately, because of a lot of customers wouldn't let us in during certain parts of COVID. So we use that to develop these materials that have been sitting on the side of our desk for years, but now anybody can actually use these materials for free. Let's say you want to start your own safe water project or a social venture of any kind, how would you go about it? So here's 5 training modules. So module 1. So say PackWatch Uganda, they wanted to start a new project. So we started with this. So first of all, download this survey and go meet with 25 houses. Where'd you get your water? Has anybody been sick? How much did it cost? How much time off work? Whatnot, right? Then go meet with the local hospital. How many of your patients are bad water? Half, right? Then go meet with the government. Who else is doing this kind of thing, right? So kind of figure it out. And we have water test kits that with the solar incubators, they can test for bacteria, that kind of stuff. 78% of the wells, I think it was in Kajukeji, South Sudan, had E. coli. Even the nice borehole wells, people drilled for them, right? Then do a business plan. This is interesting. This is a break-even analysis. So people, because of what I described about that conventional model, people are very good at starting charity-based projects and very poor at starting self-sustaining type projects. And so they're very good at how much would it cost to do this, right? But not at matching it. So in this case, this new project in PackWatch, they're gonna have to come up with $1,100 every month, whether they make one purifier or not. And then every time they make one, they have to spend this much for cement, gravel, sand, whatnot to make the thing, right? If you put that together, then you got this blue line plus this gray line gives you, or sorry, blue line and yellow gives you this gray line here. So if you're making and selling filters, if you're doing less than 20 a month, you're actually losing money every month. If you get above that, then you're making money every month. So this kind of break-even analysis, and right now we're developing version 3 of this, where it's actually going to be a Zoom board game. We have a paper board game right now that we've been using, but now we'll be doing that. And in this board game, you'll be able to switch any country, any currency. It'll have a game mode like I'm just describing, and a real-life production mode, where now it's a production mode where, hey, cement just went up. We need to put the new price in here. We either have to adjust our price or we have to sell more of them, right? So you can use it to help manage your projects kind of thing. And so it gets to this level of detail, and then business plan. So here's, here's a template. Just start, do whatever you want. It's your template. You can do whatever, right? But here's kind of a plan for starting your business. The different aspects you're going to do, what you're going to need to start up the project. In that case, $10,000. It took us in PackWatch to start the brand new project. Molds and all that kind of stuff, motorcycle, that kind of stuff. Here's their plan for how much they're going to sell. And so what we do is we actually, Enviro-Stewards sponsors a certain number per month of price discounts. So if somebody makes less than $250 a day, they're kind of in very deep poverty, which is unfortunately most of the people there, then they can apply for a discount. And what we do is for the first year, we co-sponsor 20 a month. They can get a $50 US price discount. It costs about $100, so it would then cost them 50. The next year, second year, we do 15 a month, then we do 10 a month and 5 a month. So the project has to sell more and more at full price to do it. So anyway, they've got their plan for the year out of there. And so that's all module 1. Module 2 is how do you actually make these things, right? So each step right? You click on any of them, and this is literally how you make the filters, right? Module 3, we're still working on, it's coming soon, but how do you actually run a self-supporting business, right? So Richard, you know, what did you learn, right? Me, what did I learn? I didn't go to business school, but if you're going to survive, you got to at least break even, right? And you got to, right? So how do we get those things and codify them into a business plan, right? And interestingly, we use that board game I mentioned. That's very interesting. So we integrate the problems in real life into the board game, so they encounter them during the game, which is a lot safer than encountering them in real life. And so in the game, so let's say we're playing it right now. So say Natalie, Richard, Marianne, and myself. I'm the moderator. You guys are literally playing the game, and you're literally the water team. And all you do is you decide what are you going to do that week. You can decide whatever you want. I'm going to sell filters. I'm going to make filters. I'm going to install filters, whatever it is. And I just track the outcome on your cash flow and on the people who got safe water. And after 6 months, you're judged not by how much money you made, but how many people got safe water. Because the better you organize yourself, the more people end up with safe water. But if you ever get to $0, you're also out of business, right? And so in this game, and then the interesting part of the game is after the game's over, we just have a debrief where you guys would then say, well, you know, next time I do it differently like this, right? And the people watching you play it would give theirs, and then the person moderating it, who's been holding back the whole time, because if they give advice during the game, you never learn it. But if you experience the pain, then you say, well, you know, if you did this, hey, you're running out of materials all the time, you know, because people are trying to match buying materials with orders, say, right? Well, cement never rots. If you ever have less than 3 bags of cement, you need to buy some, even if you have no orders, right? You always want at least, you know, so you back into these kind of things that you would use to keep managing your project. And so that's that business training, sales agent training. So literally, it's a 3-day course on how do you sell these filters. So we've got technicians who learn a lot more on how to make the filters and all that, but then we have a sales force. And in Uganda, like the war got too bad in South Sudan. We had a war in every town. We had 4 projects, and we had a war in every town. We had a project, literally. 2 of them, there's a war in town, and 2 of them, they're surrounded by another army. So our managers ended up being refugees in a BDB refugee camp in Uganda. And in a normal charity, we would buy them some pots and pans and some tarps and wait it out. Instead, we rented a conference hall for a week, and they taught 40 Ugandans how to sell the filters. Because all the tools are still in South Sudan, but all the training is still in their head. They taught 40 Ugandans how to sell the filter. They sold 27 filters. They only had to sell 20 to break even. First month, new country, from a refugee camp, they're already making money, right? And that's the difference between, and so in our minds as Canadians, whenever we give to charity, we say, how much is overhead? Oh, I hate that. I don't want any overhead. I want to pay for the well driller, right? Well, literally what you're doing is you're just buying a hole in the ground that's going to last less than a year. Because all wells have moving parts. I don't know how to fix one. Why would they know how to fix one? I don't have the parts. Why would they? If you're not going to put it in the system, it's going to break within 1 year. But besides, it's not even a water problem. If they're alive, they're getting water from somewhere. Is that water safe coming out of that well or not? Right? And so what this does is it purifies whatever they're drinking out of there, right? And so in this course, they teach them about water illnesses, about how to treat the water, and how to do the economics. So they'll sit down with the family, and they'll figure out with that family how much that family spent on water illnesses in the last 2 years. Then they add a 0 to it, because this thing's going to last for 25 years. And typically a family, to buy a filter at $100, they'll still save $1,000 over the life of that filter. If you put $1,000 into the family who's making less than $250 a day, that is a big difference, right? Plus, there's less risk of dying, literally, right? Because if you get typhoid, there's 20% chance you're going to die unless you come up with a needle for $50, right? And so this is how these costs add up, right? And so they teach these people, if they sell it, they get a sales commission, the other people get an order to keep going. And then the last one's the most challenging one. We call it dancing with elephants. We're still working on it. How do you prevent normal charities from killing you by mistake? Because we're so ingrained on this approach of relief, and it's all about actually the donor, not the recipient, right? We want the donor to be happy. you know, buy a pair from cheap shoes from me and I'll give a pair away for free. The donor's happy because they feel good about their shoes. The recipient, not so much, right? The person who got the shoes is great. How about the poor guy who's making shoes, right? Or the person with a shop, right? So it's not designed from the perspective of the actual recipient, which is very risky for the charity. Because if they find out what's happening, then they're not going to donate again. If you do the other approach, it looks much worse. If I hand out 1,000 fish, I look fabulous. If I teach 10 people to fish, it looks like you're paying for my fishing trip. So it looks much worse, it's much harder, it takes longer, but it's actually the only thing, you know, we don't want to pay overhead. Overhead's actually the only thing that's actually beneficial in the long term. The thing that we don't want to pay any of it, right? The training of those people in South Sudan, that training is still in their head. Every tool that we bought is still in South Sudan. You're not going to go there if somebody's shooting at you and get your mold back, right? We want to pay for the wrong stuff, right? And basically what you want to do is build this capacity. And these people, if they leave the water project, they can run any other business now, right? It's a style of thinking. And so that's what you actually want to do is build this local capacity. And so in Dancing with Elephants is, how do you, and I'm holding off on writing that because we haven't really been successful at this yet, but you know, the normal approach in this is just run away. If some charity wants to help in that area, just run away. And like literally, I told you about the project from the refugee camp, Bidi Bidi, was in a town called Kaboko. First month they sold 27. The second month the charity said, this was a great project. We want to buy 300 from you at full price if you give them away for free. Now that's very hard. That's like 8 months of sales with no work, right? And you're sitting in a refugee camp. Are you gonna say no? And literally killed the project. Because why would I ever buy one if they might come back with more free ones? They're not, but they might. And I'd be really stupid to buy one. Now the poor 40 salespeople we just trained, how are you gonna sell one, right? And it's not that people aren't getting water, they're getting water at 27 families a month. If you did your charity differently, you would explode that. But if you do it the conventional way, you literally kill the project and nobody gets water. And so we haven't been able to sell a filter there in more than a year in that town. We had to go to a different town. So, and I tried to negotiate with that charity, right? Is, hey, we both actually want the people to get safe water. We both want this project to survive and thrive. How do we get there? How does your path get there? How, right? And so, but it's really hard to get beyond the short term. You know, hey, the donor paid for this. They don't want the recipient to pay for it. It looks bad, right? And I said, well, okay, how about if you're very clear on who gets a free one? No, everybody's vulnerable. Everybody deserves one. Do you have enough for everybody? No. Then why pretend that you do, right? And so we have this kind of savior mentality that we're using. And so it's interesting, like more than half the problem isn't in Africa. It's in Canada, in our mindsets on how to help. And it's not even neutral. It's actually damaging. It's worse than nothing. You're not wasting your money. You're actually creating damage. And so that's why I did the TED Talk and whatnot to kind of, you know, we really need to rethink it, right? And so rather than doing a land acknowledgement every time we start a thing, hey, let's just pay the rent we owe, right? Hey, we're sitting on stolen land, right? That's nice. Well, if somebody came and stole my house, right? I wouldn't be really satisfied to just say, hey, I stole this house, right? And, you know, we're starting, you know, the Queen's Bush here in Waterloo, runaway slaves from the States, cleared the land, right? Then when it came up for sale, because it was Crown land, they said, hey, the land's all cleared, so it's worth this much now. And you can't afford it. So we're gonna sell it to some white people, right? And so, and so the legacy is that, you know, if you set somebody's grandfather back, then you set every generation after that back, right? And the system we're at right now is based on all that happened before. And so we really have to get back and rethink some of that. So anyway, I've been talking quite a while. I don't know if you have questions about anything.
Bruce, I think it's just amazing because I think people would look at this issue as an engineering problem.
Mm-hmm.
And what you've shown is that's kind of the easy part of
that's
it is a problem,
part,
but that's
sure.
sort of the easy part.
Yep.
if you're going to create a system that is self-sustaining, you've got to look at the whole,
Exactly.
picture. That's absolutely fascinating.
Yeah. And most engineers we can't hire. I'm an engineer myself, right? Because they're fascinated by shiny objects is one thing. Is they don't want to do a biofilter. They want to do this fine as, membranes and whatnot, and something that's going to work great for a month, right?
Yeah.
And it's the first problem, but then it's the system, right?
So Bruce, where are you seeing progress? I mean, you've had this amazing initiative. Where are you seeing the uptake, or where do you think you would start to see it?
Yeah, so we're getting a lot of requests now, and so that's where really. How do I stop here? Let me stop sharing here. So we're getting requests now from various different countries wanting this materials, and so that's where we're making it available for free if they want it, and they can just run with it if they want, because we have a limited capacity to help other people. So sometimes I just help them with conventional engineering, say a hospital in Tanzania, how we're going to treat the water from Lake Victoria. So I just help them with that, and whoever wanted to do the system recommend this great big expensive thing and say, well, actually 80% of it you don't need, right? Just do this, right? And then you can supply water to the community also. So there is a role for technical engineering also. I would say we are getting more and more requests. Our limitation is we then, remember I mentioned we do those price discounts. So that's what we do is resell stuff. So let me just share that again. Screen 2.
Bruce, while you're doing that, I heard of an initiative that involved Coke and Stirling engines for water purification. Is that a real thing in Africa?
Maybe like Coca-Cola. So again, yeah, so on that one, so say like I gave a talk last year at World Environment Day for Labatt's, and instead of a speaker fee, I just said, why don't you sponsor some filters? So they sponsored 50 of them, right? And this is literally where they are, right? Latitude, longitude, installed on the state, right? And so 500 people have safe water.
Fantastic.
1 million liters a year, 150 tons, because you don't have to cut down the tree. So interestingly, we can't sell carbon credits for this. Not because we can't get them certified, it's there's no market for them.
Yeah.
All of the carbon markets here are based on benefiting rich people. So Sustainable Waterloo region, we're a member. We're not even allowed to buy carbon credits from our own project if we made them, literally. Because more than 90% of them have to be from Canada. Because we have a bubble over Canada and the atmosphere doesn't interact with any other atmospheres.
Of course.
I think, right? And so again, we get no proof. I can put solar panels on my roof in Elmira and I would get points. I didn't. I put them on the roof of an orphanage in South Sudan. I get twice as much kilowatts per panel because there's twice as much daylight. I shut down a whole generator that they used to run their water pump. Now they got more money for food instead of fuel. Better economically, environmentally, socially, no points because I'm not using the electricity, right? And so we have to rethink these systems on who do we actually want to benefit and how. Like the people who perpetrated the problem are getting the most benefit from solving the problem. Let's put some more research dollars into petroleum companies to find ways to sequester carbon. Let's do a X Prize, $100 million to find ways to sequester carbon. Well, I already know how to do it. A tree does it for free, right? Soil, if you do regenerative agriculture, does it for free. And it grows food, right? So we already know the solutions. We don't need to send 100 million to research something else, right? We need to do the stuff we already know.
Absolutely fascinating.
That was great. Thanks for that, Bruce. If there's no other questions or anything, I think we'll probably log off. We'll be sending out some resources following up with the recording of this webinar and some other resources, potentially the slides that were used. But yeah, thank you everyone for coming and staying on and learning more about Bruce's project, which is super interesting. And I loved all the points you made. So
thank you. Perfect. I appreciate it. Yeah, I just got a 2:30. I'll have to jump off. I'll send you the presentation.
Perfect.
Keep it up,
Thank you, everybody. Appreciate you staying on.
Amazing.
Yep. Thank you.